Hello students, so I am going to start with shells, number of shells down the group and across the period. Yesterday I already finished cause of periodicity. Now let's very soon revise shells and valency both down the group and across the period. I hope you remember all those things because I have explained you before. So what do you mean by shells? Shells are the outer circular path in which the electron revolves. The outer circular path, this is the nucleus, and these are the outer circular path around the nucleus in which the electrons revolve. Okay, now what do you mean by number of shells down the group and across the period? What will be the condition? When we are considering number of shells down the group, let's consider first group elements. Okay, first group elements: hydrogen, lithium, sodium, potassium. I am always considering only representative elements because it is easy to explain with their configuration. So when we are moving down the group, just to check the configuration of each element: hydrogen, atomic number 1, configuration 1, so lithium, atomic number 3, configuration 21, sodium 281, potassium 2881. So you can see their configuration, the change in their configuration, and you can see the increase in the number of shells as we are moving down the group. Hydrogen belongs to first period, 1 shell. Lithium second period, 2 shells. Sodium third period, 3 shells. Potassium fourth period, 4 shells. So on moving down the group, number of shells successively increases by 1, which also increases the atomic size. Okay, down the group number of shell increases, atomic size also increases. Now across the period, this is the second period I have considered here. So what is the condition across the period when we are moving across the second period? Second period start with lithium, beryllium, boron. So the configuration are 2-1 for lithium, beryllium 2-2, boron 2-3, carbon 2-4, nitrogen 2-5, oxygen 2-6, fluorine 2-7, neon 2-8. So what you notice here? You notice that number of shells remain same. I already explained a period continues with the same shell and ended also with the same shell. Okay, so second period means we are continuing through the second shell. So only 2 shells will be present in all the elements which are there in second period. So what will be the condition of the atomic size? For number of shells, we can write that number of shell across the period remain same. Number of shells remains same, but you can't say that atomic size also remains same. No. When we are moving across the period, atomic size decreases up to group 17 elements. Halogens तक जाते जाते atomic size decrease हो जाता है. The atom contract up to group 17 elements. Why is it so? As we are moving across the period, you can see the atomic number is increasing. Lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7. So due to increase in atomic number, both electrons and protons are increasing. So as you can see the increase in the number of valence electrons, the same condition will be there inside their nucleus. Their number of protons are also successively increasing by 1. So due to increase in number of proton, the nuclear pull also increases. But as there is no additional shell in between the nucleus and the valence electron to overcome that force of attraction, so slowly as we move across the period, the atomic size contract. Is it clear? The same condition was there when we were moving down the group. Down the group आने पर भी atomic number बढ़ता है, due to which number of electron as well as proton also increasing, which also increases the nuclear pull. But here the condition was different. Nuclear pull was increasing, but that increase in the nuclear pull was overcome by the additional shell. As we are moving down the group, every element has one more additional shell which has weakened that force of attraction and the size keep on expanding. But here, as there is no additional shell to overcome the force of attraction, so the atomic size contracts. But it is only up to group 17. So you can say that in the periodic table, the 17 group elements are smallest in their size, smaller in their size. So which should be the bigger in the size? Of course, from the elements which we are beginning with, all the group 1 elements are larger and the group 17 elements are smaller. because atomic size decreases across the period. So first element of the period should be the largest one and the second last यानी कि 17 group के जो elements होते हैं they are the smallest one in that particular period. Okay, now coming to valency. Valency we have already done in class 9th. What do you mean by valency? Valency is the number of electron loss, gain or share by an atom in order to become stable. How they can get stable? They can become stable by attaining 8 electrons in their valence shell except helium. Helium completed duplet. So number of electrons which they are losing, gaining or sharing in order to become stable, those number of electrons will be the valency of that particular atom. If they are getting stable by loss of electron, then valency will be positive. If they are getting stable by gain of electron, then valency will be negative. So let's consider the valency down the group. Again for down the group, I am again considering the first group element, hydrogen, lithium, sodium, potassium. Considering to their configuration, hydrogen 1, lithium 2, 1, sodium 2, 8, 1, potassium 2, 8, 8, 1. So what is the condition of their valence electron? Their valence electron will readily determine whether they will lose, gain or share. So all these elements, they belong to first group. They contain 1 electron in their valence shell. So all of them will show tendency of losing 1 electron. So due to loss of 1 electron, their valency will be +1. And down the group, as you see, the number of valence electrons remains same. Therefore, valency down the group also remains same. Now coming to valency across the period. For that I have to consider, let's consider the second period elements. Again, lithium, beryllium. And then consider their configuration: lithium 2, 1, beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, fluorine 2, 7 and neon 2, 8. Okay, so let's see the condition of their valence electron. Lithium 1 valence electron means it will lose 1 electron, valency will be +1. Then 2, they will lose 2 electron, valency will be +2. Then boron 3, it will also lose 3 electron, valency will be +3. Carbon 4, if already 4 electrons are present, then loss or gain become difficult. They will share 4 electrons, valency will be ±4. कंडीशन ऑफ नाइट्रोजन, नाइट्रोजन के वैलेंस शेल में 5 इलेक्ट्रॉन्स हैं. 8 करने के लिए उसको 3 और गेन करने पड़ेंगे. तो मैंने कहा ना, गेनिंग वैलेंसी को हम नेगेटिव इलेक्ट्रोनेगेटिव नेचर शो करते हैं. देन वैलेंसी 3 इलेक्ट्रॉन गेन करना है ना, तो वैलेंसी विल बी -3. ऑक्सीजन वैलेंस शेल में 6 इलेक्ट्रॉन है, 2 have to be gained, then valency will be -2. फ्लोरीन के वैलेंस शेल में 7 इलेक्ट्रॉन है, 1 इलेक्ट्रॉन will be gained, valency will be -1. नियॉन की वैलेंस शेल कंप्लीट है, no need to gain loss or sharing of electron, valency will be 0. So you can see what is the trend of valency across the period. Valency first increases up to 4 and then decreases to 0. So here I have ended all the topics which were present in class 9th also. Now you can check your book. Just after this topic of valency, one in-text question exercise is given. So I am telling all the students to solve that exercise completely and let me know all the doubts related to that exercise by the evening today. And from today, if I get no doubts, then I will start the next topic, periodic properties. Okay.